Okay, today we're going to finish chapter 5. Let me just say, last lecture was, in my 33 years at MIT, one of the most active and interactive lectures I've ever delivered. So you guys are great. I really hope you'll keep it up. This course is going to be so much fun if you guys keep asking questions, interacting. Just the broad spread of people. The questions I got were great, so please do keep it up. We're going to have an awesome semester if you guys continue to do that. I really appreciate it. Okay, so we're back to chapter 5. And you remember we were talking about government interventions to address externalities. And I said, look, at the end of the day, price and quantity restrictions are pretty much the same. I said there were two big differences. One was quantity restrictions involve more information, because you don't need to know how big the externality is. You also need to know the shapes of demand and supply curves. And I said quality interventions also can lead to allocative inefficiency if firms are heterogeneous. But we solved that problem with a cap-and-trade system. We talked about how a cap-and-trade system can solve that particular problem with quantity solutions. There is a third difference between quantity and price solutions, which is actually not that one's better than the other, but it's a third critical difference. And this is due to a very important article written by Marty Weitzman, a former economist at MIT and Harvard, made a very important point about once you have uncertainty in your model, then there are different advantages of cost and price approaches to dealing with negative externalities. Okay? So to see that, we're going to look at figure 510. It's the last figure from chapter 5. Figure 510. Figure 510 is the same pollution reduction framework we used last time. The difference here is twofold. First of all, we're no longer going to have a flat marginal damage curve. Many of you asked, does the marginal damage curve have to be flat? No, it doesn't. And here we're going to have a declining marginal damage curve, which makes sense. The first unit of pollution is the worst, and it gets slightly less bad after that. Okay? Not necessarily, but it's a sensible starting point, at least over relevant range. We're also going to have, so that's the first difference. You'll see it's a declining marginal benefit curve. The second difference is we're going to add uncertainty. And in particular, we're going to have the very realistic case of uncertainty over firm cost curves for pollution reduction. After all, let's say you're a regulator and you want to know about firm cost curves for reducing pollution. You could do some engineering model, which will be uncertain because every firm's different. You could ask the firm, but the firm, of course, is going to say, oh, it's incredibly expensive to reduce pollution. It's going to cost me bazillions of dollars. You shouldn't make me do it. You can't get reliable information from them. So you're going to face an uncertain environment in which you're measuring the cost of pollution reduction. That is what we're capturing here. And we're going to do it in two examples. The first example is climate change, which we'll talk about a little bit more later this lecture. And the second is forest fires. The big difference between the two is the steepness of the marginal demand curve, or the marginal damage curve, or the social marginal benefit curve. With global warming, every unit of carbon does damage, but it's not like a particular unit tips us over. Okay? Now we're getting closer to tipping points with things like Arctic melting, but in general, we don't really care if you drive 100 miles or 1,000,000 miles this year. That's not going to really affect the future of the Earth. Okay? With forest fires, that's another negative externality. If you set a forest fire, that affects other people. And certainly there can be very steep marginal damage. Just as forest fires get bigger, that can do exponentially more damage. Okay? So that's a steep marginal damage curve. Now, I'm just picking these examples. I'm sort of making them up. The main point is we want an example with a flat marginal damage curve and a steep marginal damage curve. Now, so those are two examples. In each example, we're going to have an MC1 curve. MC1 is the government's estimate of what the marginal cost looks like. Okay? MC1 is the government's estimate of how much the marginal cost of reduction actually is. MC2 is the truth. Okay? So MC1 is what the government thinks the marginal cost of reduction curve is. MC2 is the true marginal cost of reduction curve. Okay? Question about the setup. Okay, let's now look at what happens when the government either puts in a tax or quantity regulation based on what it thinks is the true marginal cost of reduction. Okay? So in the case of climate change, let's take the quantity regulation. The government rolls in and says, look, we think the right cost curve is MC1, the benefit curve is SMB. We're going to assume no uncertainty in that to make life a little easier. Those two intersect at point C, and that says that the optimal reduction is R1. Okay? That's just applying the framework we did last time. Now, in truth, the marginal cost curve is MC2. So the true optimal reduction is where MC2 hits the social marginal benefit curve, which is at R2. Okay, is that R2? So the government, by getting it wrong, is reducing too much. There's too much reduction. Remember the key point last time, you can have too much pollution reduction. Getting rid of pollution is never fully getting rid of pollution is never optimal. Because why would you have too much pollution reduction? Because the costs you're imposing on firms to reduce pollution are greater than the benefits to society of having them reduced. So what you see here is the government, through its quantity regulations, creating a dead weight loss DWL1. DWL1 is units where the marginal cost, the true marginal cost, the red line, is above the marginal benefit. So those are all units where the marginal cost of reduction is above the marginal benefit, and yet you're still mandating reduction. So you're creating a dead weight loss by mandating too much reduction. Questions about that? Okay, now let's think about an alternative policy tool, which is a tax. Imagine I know the marginal damage curve, the social marginal benefit curve, but I still don't quite know what the right cost curve is. So I set my tax thinking that marginal costs are MC1. Well, where do I set my tax? I set my tax at the level C2, that little t equals C2 on the y-axis. I set my tax there, okay? When I set my tax there, okay, I am saying to firms that's the tax they're going to have to pay. In fact, the tax they should pay, okay, is where, let me be very precise on this. So I set the tax where marginal cost equals marginal, MC1 equals marginal benefits. So it should be, I set it at point C. Where it should be is where marginal cost equals marginal benefits, MC2 equals marginal benefits. The government's going to set a tax at the amount little t, okay? And that's what they're going to tax. The firm, the optimal tax would be different than that. The optimal tax would be at B, where MC2 equals marginal benefits, right? That would be the optimal tax. So the optimal tax would be slightly higher, where the optimal tax is slightly higher. So what happens here? Well, the firm should choose point B. Instead, it chooses point E. Why does it choose point E? Someone tell me. Why does the firm choose point E? When we set this tax equal to little t. Yeah. Yeah. So basically, there's no reason to reduce more than that, because, or less than that, because that's the marginal cost of reduction. They're reduced to the point where the marginal cost of reduction equals the penalty they have to pay. That penalty is little t. So they're going to choose to reduce to point E. The optimum is B. So they are doing too little reduction. The optimal reductions are 2, they're doing R3, creating a dead weight loss of the triangle to the left, DBE. Okay? Now, let's contrast that to what happens to forest fires. Let's walk through the same steps, a little faster now. The government thinks that the optimal quantity to regulate is R1. The true optimal quantity is R2. So the government causes too much reduction, creating a dead weight loss to the right of point B, the triangle ABC. The tax case. The government thinks the optimal tax is little t, but little t hits MC, but in fact, the optimal tax should be higher, okay? So that means they do too little reduction. In other words, the area BDE is the area where the social marginal benefits of reduction are above the cost of reduction. So that's why they're doing too little. In both the top and bottom panel, the tax caused them to do too little reduction because the social marginal benefits are above the true social marginal costs. So it's a deadweight loss which arises from doing too little reduction. We stop there. Do people understand? Question about this complicated graph? Questions about this? Okay, here's the money question. Notice the key contrast between the two. Yeah, question.
The marginal cost curves that we have here, these are to the firm or to society?
To the firm. Well, it's basically these are private marginal cost curves. These are private marginal cost curves. This is now, remember, when we're doing in this framework, we're not doing social versus, the marginal cost is just the marginal cost. It's the marginal cost of reduction. So the private and social marginal costs are the same because we're assuming no externalities in the reduction of pollution. So this marginal cost curve is just the marginal cost of reducing pollution. We're assuming that costs the same in the firm as it came to society. Okay? Yeah? Would we switch to point E? Because the firm's decision is, the firm, remember, the true MC is MC2, the red line. They see a tax of little t. If they reduce, so you said point E instead of point, okay, well, why would a firm not go, why would a firm facing a tax of t, why would it not go past E? Why would it go to B? If it goes to B, it's spending more than paying the tax. Because look, if it goes to B, its marginal cost is above the tax. So why would it do that? It'd rather just pay the tax. So it'll only reduce until the intersection of that line, which is point E. Does that make sense? Okay, yeah?
So the deadweight loss 1 would only incur if there's a mandate, and deadweight loss 2 would only incur if and only if there's a tax.
Exactly.
Not concurrently.
Yes, that's a great point. Excellent clarification. Okay, here's a money question. Notice that the deadweight loss on the left is small in the deadweight loss on the right on top, but bigger on bottom. Any intuition for why? This is hard. Any intuition for why the bottom case, in other words, in the top case, quantity regulation causes more inefficiency than price regulation. In the bottom case, price regulation causes more inefficiency than quantity regulation. Why? Yeah? That's what's causing it graphically, but what's the intuition? And this causes it graphically, elasticity. But what's the intuition for why? Yeah. Alec.
Better to over-prevent forest fires than under-prevent them?
Yeah, exactly. Think of it this way. Think of quantity regulations as erring on the side of the regulator. And price regulation is erring on the side of the regulated. So the quantity regulation, the regulator is saying, look, I don't care what it costs you. You're doing X. With the price regulation, they're saying, I don't care how much you do, just do it till it costs Y. So quantity regulation is about getting the quantity exactly right, no matter what the cost is. A price regulation is about saying, look, deal with the externality and we get what we get. In the first case, we don't really care about getting it exactly right because it's a very flat curve. If you're a little bit off, if you drive 500,000 miles instead of 1,000,000 miles, it's not going to affect the future of the Earth. In the second case, if you light a big fire versus a small fire, that will affect the future of California. Okay? So we care. The other example I often use here is sort of nuclear waste, but there it's just sort of a vertical line. Okay? But that's the most extreme example. We care in this second case much more about getting the quantity right. So even if we impose extra costs on you, the bottom line is quantity regulation is make sure you get the quantity right and saying, I don't care what it costs you, firm. We've got to get this right. Once again, sort of nuclear waste would be the ultimate example. Okay, it's sort of a vertical line. You know, the marginal damage is vertical. A little bit kills us all. Yeah?
Is the result the same if MC1 was above MC2?
Then it would be, if MC1 was above C2, you'd reverse everything. Yeah, exactly. So basically, this is an example of a more subtle distinction between price and quantity regulations, and another reason why they might be different. It's a very subtle point, but it's a good example of how we can use this kind of graphical analysis. And in section, do it mathematically. Graphical analysis to really understand why you might prefer one versus the other. And to deal with a real world, look, as I say in 1401, all models are wrong, but some are useful. Okay, what is a model? A model is an abstraction from reality. The goal of any modeling exercise is to trade off the power of a more complicated model against the benefit of a model that's easier to work with. Until this point, we've abstracted away from uncertainty. That gave us a lot of interesting lessons. Now I add uncertainty, I need to learn a new lesson, but at the cost of 25 minutes. Okay? So basically, this is the challenge we face, is how to think about these things. And this is sort of an example of a deeper dive that one might do if one wanted to really get into this more. Questions about that? All right. Now we're going to move to chapter 6. And what we'll do in chapter 6 today and next time is talk about externalities in reality. And we'll focus on the two key areas where externalities are a focus of government policy. The first being environmental externalities, and the second being health externalities. So we'll start with environmental externalities, and we're going to focus in particular on two kinds of environmental externalities. The first is particulates emission. Now, I'm sure there are people who understand the science here way better than me, so excuse my rudimentary chemistry. But roughly speaking, when we burn coal to make power, we release sulfur oxide and nitrous oxide into the atmosphere. They then combine with oxygen to make bad stuff. In particular, to make acid rain, which is rain that comes down, is bad for the environment, but really not that bad for humans. More importantly, create particulates, which are soot, which is in the air and which can harm us when we breathe it. In particular, very fine particulates, which can get into our lungs, are very damaging to people. As a result, there are enormous health consequences of burning coal. We know burning coal is bad for the long-run health of the Earth, but it's actually bad for the short-run health of us. That when you burn coal, it can cause asthma, it can cause other health problems. And I'll come to those in a few minutes. Now, the problem is they burn the coal in the Midwest, and the soot then floats in the air and falls on the East Coast. So it's a classic fisherman and the steel plant and fisherman problem, which is the folks burning the coal. Not only is it many folks burning the coal and many folks being affected, not even the same folks. So it's a classic case where it's going to be very hard to envision a Coasian solution to this problem, because they're not only disparate in terms of who's doing it, they're disparate even geographically. And that's why we think we need a government role in dealing with this. So I want to talk about how is the government regulated particulates, because it's an excellent example of how our thinking on this has evolved. The first effort to this was in the 1970 Clean Air Act, way back, cast your mind way back. And with the 1970 Clean Air Act, so the Clean Air Act did, was it set up what was called new source performance standards. What they said is, look, we got a bunch of old bad coal plants. What we're going to do is make sure that we never make this mistake again. And any new coal plant that's built has got to be much more environmentally protective. You've got to install scrubbers. You've got to do all this stuff to make sure you're not emitting all this bad stuff into the atmosphere. Okay? Not that you can't build a coal plant. We're just going to make it much more protective of the environment. And that was a major bill that passed in the 1970s. And we did see some declines, in particular in sulfur dioxide that caused particulates. We saw declines. But it wasn't a huge effect. It wasn't. And why is that? What's the fundamental challenge if you try a regulation like this? Let's say you're a power producer in Ohio. You've got your coal-fired plant. I pass this new source performance standard. What are you going to do? Yeah, in the back. Yeah, so basically think about an optimizing coal power plant owner. He's constantly thinking, should I upgrade or should I build a new plant or not? What we've done is we've just taxed building a new plant. We've just said, look, if before you were indifferent, you're about to build a new plant, now don't build it. That's what I'm calling, so just keep running your old one. Guess what? The old ones are really bad for pollution. So essentially, this offsetting effect, which is we incentivize keeping old plants running, which essentially what it did was it offset the pollution gains from these new source performance standards. So while new source performance standards helped, they didn't help that much because offsetting effects. So this comes up, this is not just an example from my childhood, this is relevant today. We want to replace fossil fuel-using vehicles with electric vehicles, right? What happens to all the old fossil fuel-using vehicles? They don't disappear. You know what happens to them? They get shipped to developing countries. So all these used old fossil fuel burning vehicles that we're now replacing with EVs get shipped to developing countries, and a bunch of people who weren't going to drive now drive fossil fuel burning vehicles, offsetting the benefits of switching to EVs. Okay? This is a classic problem we call a problem of partial regulation, which is when you try to sort of, this is always a game of whack-a-mole, and when you try to solve one problem, you might create others you don't anticipate. And that's why in one probably of the greatest victories of all time for economics, in 1990, under the first President Bush, a series of economists, including our own Richard Smolensky, former dean of the Sloan School, convinced the Bush administration to pass a set of amendments to the Clean Air Act in 1990. And what these amendments did is they did two things. First of all, they dramatically tightened the standards of what could be emitted. But second of all, they set up the nation's first cap and trade system, where they said, look, we are now going to say three things. First of all, they tightened the standards. Second, they applied them to every power plant, not just new ones. And third, they allowed trading. So they said, we're going to have a new cap for you utility, John's coal plants of Ohio. Okay, we're going to have a new cap on how much you can produce overall from all your plants. Okay, but we're going to allow tradable permits. Okay, this was the first example of tradable permits. As I said, it was super controversial. There was this concern over pollution absolution, that plants would, essentially were permitting bad behavior. We should just tell them all to stop, not do this. But in fact, it's much more efficient. It's a much more efficient way to do it. Plants could then if you go back to our example from last lecture, indeed, if you flip over this page, I think we still have the graph. Yeah, we still have the graph from last lecture on the back of the Chapter 5 page. You go back to the Chapter 5 handout. There's a graph for last lecture. So, Paul, you were smart. You thought ahead in printing this out. That basically, when we have heterogeneity in the cost of reduction, then it's going to be beneficial rather than forcing plant B to spend a ton and plant A to get away cheaply. By letting them trade, we move to the efficient allocation, as we discussed last time. So this was, in some sense, the economist's argument for having your cake and eating it too. That we could regulate more and reduce economic activity less by having this trading system. And get rid of this sort of partial problem of people just keeping old plants running. Okay? Now, this predictably raised a lot of opposition. One form of opposition was said was some environmentalists who felt it wasn't pure and, wasn't pure enough. The other form of opposition, of course, was from the industry, who said, look, you're going to crush us. You're going to destroy coal. Sounds familiar. It's current modern debates as well. Okay, you're going to destroy the coal industry with these regulations. No one will use coal anymore. It's horrible. We'll lose. I think the estimates the coal industry point out, by the way, never trust an estimate from a regulated industry about what something's going to do to that industry. Okay, I don't think you need to be a genius to figure out why their incentives aren't aligned to give you a correct estimate. They estimated that there would be a $7.4 billion annual loss and 4 million jobs to be lost, which is probably more than was in the coal sector at that time. Okay? And so they said that it would be bad, but in fact, this has been an enormous success. In fact, what we found is two things. First of all, studies of the Clean Air Act have found enormous benefits for human health. Benefits for studies of everything. There's really cool studies of the Clean Air Act. The simplest studies were of the form something like figure 6.1. This look at the original Clean Air Act. So you covered Chapter 3 in sections and application of Chapter 3 methods. This is by the nation's leading environmental economist, Michael Greenstone, who used to teach here, not teach at Chicago. Okay? Here we have a situation where there were areas that were similar. Some were regulated, some were not. Areas are similar, some are regulated, some were not. So basically what he said is there's some areas that are similar. Some were just over a threshold where they were regulated. Some were below that threshold when they weren't regulated. And he looked at what happened over time to basically pollution in areas that are regulated and not regulated. And what he finds is the regulated area pollution dropped a lot. So in the non-regulated areas, things didn't really change. That's the green. And the regular air pollution dropped a lot. And guess what else? So did deaths. Those are dramatic reduction in deaths. So there's a number of studies of that, but there's also really cool studies that go beyond that. So for example, one of the coolest studies I know is they looked at what happened to kids who live near toll booths before and after Easy Pass. You guys know Easy Pass? It lets you whip through the toll. When I was a kid, you used to have to pay. There were long lines of cars at toll booths, which meant more emissions. So basically, Easy Pass meant suddenly these kids were exposed to less emissions because there weren't long lines of cars idling waiting to pay. And they found measurable improvements in child health. All sorts of cool papers like this. It's one of the most active and exciting areas in empirical economics. There's all sorts of interesting, exciting papers showing the enormous health impacts of reducing particulates, either through this regulatory mechanism or other mechanisms. Okay? Now, on the other hand, it did cost something. There was a loss in economic activity because we did lose some coal jobs and some production. And also, it raised the price of fuels. Basically, what we're doing is this. Yeah, that's the right room. So what we're doing is we're essentially making it more expensive to use fuel products. That is going to lower economic activity. The best estimates are that if you take the health benefits and you value them in a way we'll discuss in Chapter 8, the benefits of this law was about 7 times its costs. And that 7 times was largely because of the trading. That basically trading lowered the cost of implementing this law by about 2/3. That basically absent trading, the Clean Air Act would have, to achieve the same goals, would have cost 3 times as much. And so the benefit rate cost ratio would have been closer. But because of trading, the benefit cost ratio was, the benefits massively exceeded the cost. Question?
For the purpose of this class, do we care about who bears the cost and who gains the benefit?
Great question. Right now we don't, because we're not about distribution. For the purpose of the class we do, but it's always very important to separate distribution and efficiency. Right now we're just talking about efficiency. Later we'll talk about that. But I mean, we can come to it here a second, which is, in some sense, if you think about that, what you can do is you can take a model like this. We talked about social welfare if you reviewed your Chapter 2. You could take a model like this and add social welfare weights. Social welfare weights are essentially, if you think about a utilitarian social welfare function, a poor person has a higher weight than a rich person because each dollar means more to them, has a higher margin utility of consumption. You can add welfare weights. If you add welfare weights, that only strengthens this argument because generally the pollution was the worst in the poorest neighborhoods. Okay, and the costs were generally borne in by higher income owners of coal plants and fairly wealthy workers in those coal plants. So that would only strengthen the conclusion if you add distributional concerns. Yeah?
How is it that permits, for legislation like that, how does that permits actually get distributed among the existing?
That is an awesome question. I'm going to come to that in a few minutes. Other questions? Yeah?
Also, we spoke last lecture that there's some benefits to using direct taxing or pricing
Right.
of the negative thing rather than capping and trading. Why is it that
Same question. I'm going to come to that. I have about a 5-minute spiel on this that you're absolutely previewing. Okay, but to get to that spiel, let's turn. Other question about this. Let's turn to the next topic, which is really the most important environmental externality in the world, which is global climate change. Okay, basically, I have this saying, because I'm a health economist, there's only 2 things that matter in the long run, which is climate change and healthcare costs, because in both cases we're underwater. Okay, basically global climate change is real. It's caused, even Trump didn't deny that last night, that it's real and man-made. Okay, and it has enormous consequences. Okay, the world is getting hotter. The last year, 2023, if you look at degrees Celsius above the 20th century average. In 2022, we were about 0.91 degrees Celsius above the 20th century average. In 2023, it jumped to 1.2 degrees Celsius above the. That is an enormous jump. I mean, that's incredibly consequential, and there's no sense of it slowing down. We are facing an enormous and rapidly growing problem of global warming. Now, if you live in North Dakota or northern Minnesota, not necessarily so bad. Indeed, it's not even clear that we were before, that 100 years ago was at the optimal global temperature. It's not entirely clear what the optimal global temperature is. We may actually be, if you look at total world production, we may actually be closer to it now. But what's clear is we're going to go past it very rapidly. And things like Bangladesh will be underwater, Cape Cod will be gone, Florida will be gone, things which might make us sad. Okay? These are enormous consequences. World GDP by 2100 is estimated to be 10% lower. Literally, it's like we're burning 10% of all our resources through climate change. And it's obviously not distributed equally. Once again, it's some of the poorest countries that are bearing the brunt of this climate change. But the key thing we've really started to focus on lately is it's not just the long-run global warming, because long run, people don't care about the long run. It's the short-run salient climate-related disasters, and that's why we've gone from calling global warming to climate change, or as the term I like, someone called it global weirding, which is weather's just gotten really weird. Okay, there is both more rain and more droughts. Why is that? It's because the rain falls harder and faster and is going to get absorbed in the dirt. There's more rain and more droughts. There is more hurricanes. There's more wildfires. Okay, one of the most dramatic examples was in 2023, an area of Canada burned the size of North Dakota. Some of you in America may have seen the smog from these Canadian wildfires. Okay, this was an enormous wildfire, one of the biggest on records. Here's what's amazing. That wildfire also released a ton of carbon stored in trees. So that wildfire, by burning the trees, released carbon. Indeed, the carbon released by that wildfire was more than any other country in the world emitted that year except for 3. So that one wildfire emitted more carbon than any other country except for 3 in the world. Okay? So we are in this real cycle of damage. And it's not just, and once again, it's not just about the environment, it's about human lives and human health. So for example, there's a huge rise in chronic kidney disease, the cause of kidney failure, that every 5-degree temperature increase the odds of kidney failure by 47%. Okay? And we are seeing more kidney failure and more chronic disease because of this global warming. The problems are bad. I can go on and on. You guys have heard about this. It's a problem. It's perhaps the classic non-privately solvable negative externality. Because as I said, emissions from anywhere in the world affect everywhere in the world. Literally, you could not design a better fail of course than global warming. Okay? You need the government to get involved. Now, the problem is, which government? If you look at figure 6.2, this shows the distribution of emissions around the world. This is millions of tons of carbon that are emitted by country. You see that China, the United States, and India, China in particular, the United States, are well above the rest of the world. And they account for a huge share of the total worldwide emissions. I think 40% of worldwide emissions are from China and the US. By the way, when I started teaching this class in 1992, China was negligible. The US dominated every other country. Okay, so China, we see, and we'll come back to this, how rapid growth can impact the environment. So basically what you have is a situation where you have an unequal distribution of the emissions, an unequal dynamic distribution, an unequal distribution of the damages. So it's not like one country's government can solve this. You need a global solution. Now, that is very hard. The good news is we have one positive example, and that's the Montreal Protocol. So when I was a kid, there was lots of things that feature what's called chlorofluorocarbons, which are basically things that are in aerosols. So when you had hairspray when I was a kid, it had these aerosols in it, refrigerators, etc. Turned out, those aerosols were just creating a giant fucking hole in the ozone layer. Okay? And suddenly this hole just started, scientists knew about this, but then suddenly the hole actually emerged, or started to emerge. And people were like, wow, that's bad, there's a hole. We ought to do something about that. And 160 nations got together and negotiated a global ban on chlorofluorocarbons. Indeed, the Montreal Protocol was ratified by 184 countries, and worldwide consumption of CFCs over 15 years dropped from 1.1 million tons to 64,000 tons. It worked, and that hole is now on its way to healing. Okay, recently, there's the Kigali Agreement sort of ratified and further expanded on, because there's some other CFC-like things that are also bad, and so there's a new round called the Kigali Agreement where they further banned those things. So basically, this is great. This is a good example. The problem is, it's sort of the best example for cooperation because there was a hole. Global warming doesn't kind of work that way. Global warming is like a ship that's going slowly. It's going to take 100 years to turn around. Okay? So we don't have quite the salience of the whole, but at least we have one example we can point to of international cooperation. So the question is, how can we get international cooperation? Okay? And this led to a series of international conferences, the first one in Rio in 1992, to take on the problem of global climate change. Now, the most significant early conference was the Kyoto meeting in December 1997. I actually was at that. I was in the Clinton administration at this time. And it's actually an interesting story because, interesting to me at least, and I guess now you have to hear it, because what happened was there was actually a big fight between the environmentalists and the economists. The environmentalists were led by Al Gore. The economists were led by my former mentor, former president of Harvard, Larry Summers. The economists said, look, remember, we knew way less about global warming in 1997 than we know now. The economists said, look, yes, global warming thing might be bad. We're still unsure, so let's start slowly. Let's slowly start to regulate and ramp in. The environmentalists were like, no, the earth is burning, we got to go hard now. And the environmentalists won. And the US went into a negotiation which was going to be an aggressive reduction in worldwide carbon emissions. Now, I wasn't intending to go because I was on the losing side as an economist. But they decided the day before they needed economists there, so the only plane left the day before was Air Force Two. So I got to fly over on Air Force Two, got to hang out with Al Gore in his sweatpants. The coolest part was I get in Air Force Two, and there's this nice chairs and stuff. I'm sitting there, the phone next to me rings. I pick it up, I'm like, hello? They're like, hi, John. It's like, oh my God, they're calling me from Japan to make sure I was on my way. That was sort of freaky. So we went. It was an incredibly intense experience negotiating this treaty. What I learned is basically the way treaties get negotiated, everyone just gets so tired that you finally sign it to go to bed. So I was there for 4 days. I slept 5 hours. In Japan, they have in vending machines coffee in cans, so we just drank the coffee in cans all the time to stay up. And eventually, we just signed it because, people were tired. But we signed the Kyoto Agreement, which was a dramatic step forward. It was an agreement to reduce emissions by 2010 to where they're left to below where they'd been in 1990. So those emissions are growing naturally as economies grow. It was a commitment to reduce that growth in emissions. 37 of the 38 countries that agreed to that bill then brought it back to their nations and signed it. We were the one that didn't. Okay, the US never signed the Kyoto Agreement and never was bound by it. So once again, while chlorofluorocarbons is a great example, it's not uniform, it's hard. I'll come back to in a few minutes why the US didn't sign. But let's talk about a key feature of the Kyoto Agreement, which was that it included emissions trading. And let's talk about how the Kyoto Treaty actually is an excellent example of the benefits of emissions trading. So basically, all the signatories were allowed to trade emission rights across themselves. Okay, so once again, our classic Plant A, Plant B example, now it's country A, country B. Okay? Why this matters is countries, just like Plant A and Plant B had very different marginal costs of reduction, countries had very different marginal costs of meeting their global warming targets for very different reasons. One reason was, take, for example, Russia. Russia had just collapsed after 1989. Their economy had gone, growth had been massively negative. As a result, it wasn't that hard for them to limit emission reductions, so they weren't producing anything anymore. It was cheap. On the other hand, take Japan. Japan had been taking global warming very seriously well before we had. They'd already converted a lot to nuclear energy, other things which are very efficient. It's very expensive for them to do more. They'd already gotten pretty far. So there's huge heterogeneity across countries in the cost of this. So to make this sort of in a simple example, let's imagine, let's go to figure 6.3. And let's think about the world as being the US and the rest of the world. That's how US people think about it anyway, so we might as well do it. Okay? We've got the US and the rest of the world. And let's say there's two marginal cost curves, supply curves. This is the graph for pollution reduction. So the supply curve is the marginal cost of pollution reduction. You've got a US curve and a rest of the world curve. The US curve is much higher. That is, the marginal costs are much higher because basically, essentially, it's much more expensive. A, we're growing rapidly in the 1990s into the 2000s. And B, it's much more expensive to retrofit and tear down plants and build new ones than it is to just sort of grow into it naturally. So we were pretty expensive, in particular compared to places like Russia. The goal that was set meant a reduction of 440 million metric tons of carbon. That was the goal that was set in Kyoto. Okay? I'm sorry, it was 630. I'm sorry, the target was 630 million metric tons of carbon to be reduced. So one way to do that was to say every country had to achieve the Kyoto goal on their own. Well, given the distribution of carbon emissions at that point, that would have meant the US would have had to do 440 million metric tons reduction, and the entire rest of the world would have to do 190. Okay, that's just because we're the super bad guys at that point. China and India hadn't really started doing this yet. We're the bad guys. So we had a lot more to reduce. So if we just said in an autarkic world with no trading, we just said the US has to get to the Kyoto target, which was 7% below its 1990 levels by 2010. It would have had to reduce carbon emissions by 440 million metric tons. The rest of the world only by 190. What does that mean in terms of costs? That means the US would have had to spend $210, would have had to charge $210 per metric ton of carbon. In other words, if you just about the price it would cost, the marginal cost, the rest of the world would have been 20, 1/10 as much. Now let me fix ideas for you. $1 per metric ton of carbon is like a cent on a gallon of gas. So this would have been equivalent to a $2 increase in the price of gas. That's big. You heard last night the price of gas is a big part of how we think about public policy. Okay? But due to trading, okay, we could fix this problem. So go to the second panel. Now imagine, instead of each country having to do it on its own, we just have a worldwide supply of carbon reduction. And that's S sub T. That is the sum of the US supply curve and the rest of the world supply curve. S sub T. What you see is now, to reduce by 630 million units, from a worldwide perspective, it would only be $50. So if we had perfect trading and permits over $50, the US would reduce only by 40 million metric tons, 1/10 as much, and the rest of the world would pick up the slack. Why? Because it was efficient for them to do so. Reductions were cheap in the rest of the world. They would be happy to pick up the slack if we paid them for it. So with a functioning and efficient permit market, we cut the cost by a quarter to the US of meeting this target. Okay? So this is an example of the power of trading. Questions about that? Yeah?
So presumably that would lead to a smaller increase in, for example, the price of gas in the US. Would the difference between that level and the level that would have been paid in panel A be like somehow or another still passed on to taxpayers?
That's a great question. Once again, I'll come to that. Great question. Okay, so that is one example. Other questions about the mechanics here? Yeah?
Walk through again what the orange curve is.
Yeah, well, ST is just the sum of SUS and SR. It's imagine instead of each country doing it alone, there's a worldwide supply. Flatter? Flatter than either of them, because basically you always do what's cheaper. If you have an aggregate supply curve, it's always flatter than each firm's supply curve. You could always choose whichever. So basically, you do other firms initially, but eventually the US gets cheaper than other countries. So at that point, use the US, and so it's below the other country curve. Does that make sense? Okay. Other questions? Good question. Other questions? Okay. Well, as I said, the US wouldn't sign this Kyoto. Part of it was $50 was still a lot. But part of it was the fact that you may know there are more than 38 countries in the world. I mentioned 38 countries signing this. The entire developing world was left out of this agreement. Why were they left out of this agreement? Well, we knew this was a problem that was going to come. We knew eventually China and India would start to use a lot of emissions. The problem is they hadn't, and they're like, screw you. Like, you guys got to party and have air conditioning. We're about to grow and have air conditioning. You don't want to let us have air conditioning. You don't want to let us have what you had. Tough luck, buddy. You know, we're going to have it. So the problem was developing countries, and I was in the room negotiating with them, and they were very dismissive of this whole enterprise. We're like, look, why should we play? The problem is that getting developing countries to play would be enormous. Indeed, if the whole world was involved, the cost would fall by another factor of 4. Okay, so you get developing countries in, that ST curve would be even flatter, and the cost would cost by another factor of 4. Because why is that? Because that's where the cheapest opportunities are, because they haven't built the plants in the first place. If the US wants to improve our fuel efficiency, we've got to tear down a coal plant and build a nuclear plant or a natural gas plant. These countries are going to build it anyway, just build this way instead of that way. That's way cheaper. So the tremendous opportunity to bring them in, but they were like, we don't want to play. So how could we solve this problem? Basically, there's tremendous opportunity bringing them in. They don't want to come in because they want the air conditioning. What do? Pay them. And what's a great way to pay them? Say, we are going to set a looser target for you. So instead of you having to get to 7% below 1990, you have to get to 20% above 1990. Why is a looser target equivalent to paying them?
It's like giving them more permits.
It's like giving them more permits. The looser their target, the cheaper it is for them to reduce. It effectively gives them more permits, gives them more reduction opportunities. So they get people buy even more of their reduction opportunities. It's a way to pay them without politically saying, I'm giving China $1 billion. You say, well, I'm just setting up this permit market, and China's going to end up with more permits, and we're going to be giving China $1 billion. So that was how you ultimately try to get them involved. Now that didn't work, wasn't part of Kyoto, and really hasn't been part of any situation yet. Now we come to this excellent set of questions that were asked, which is what was actually done in the US? And how do we think about the policy trade-offs, which is really fascinating in this context. Okay, so the first thing, if you ask economists or look at the figure from the last chapter, global warming is a classic case where a tax makes more sense than a quantity restriction. We showed you the deadweight loss for something with a very flat marginal damage curve is much lower in the case of uncertainty, which is a lot of uncertainty, with a tax and a quantity regulation. So the obvious thing to do is to have a tax. And economists have called, since it's been an issue, economists have always called for a corrective tax on carbon. Indeed, as I said, probably the nation's leading environmental economist, a guy named Michael Greenstone. What Michael Greenstone's done is he's actually done an incredibly elaborate exercise with a series of collaborators where they've actually measured the social cost of carbon. They've actually measured the marginal damage curve. They've measured the cost in terms of damage to human health, in terms of damage to agriculture. They've literally gone and taken engineering estimates and measured it. And their current estimate is that the social cost of a ton of carbon is more than $200 per ton today. That is, every ton of carbon that's used has an extra marginal damage of more than $200 per ton. So what Greenstone would say, if he were here, is politics aside, we should have a carbon tax, which is $200 a ton. The problem, as I said, that's $2 a gallon on gas. To fix ideas, the first attempt to go after this was in the Clinton administration. Bill Clinton proposed a gas tax to get ahead of this. It was an ambitious 3.4 cent gas tax, and he lost Congress over it. Okay? The price of gas is super salient in people's minds. So carbon taxes are just not happening. Okay? Simply, there is a set of things we'll learn about this semester where they have an incredibly dedicated voting bloc. Unfortunately, that voting bloc consists only of economists. Okay, this is one of them. Okay, this one, some environmentalists are on board too. But the bottom line, this is just, it's too difficult politically. So that's your first question, why didn't they do taxes? That led to the Kyoto framework and the general framework of fine, in general, cap and trade is as efficient as taxes. So let's just go to cap and trade. You know, the Weitzman point we missed, but leave that aside, that's too complicated. In general, cap and trade gets you to where taxes are. So let's do a cap and trade system. And so the US turned that down, but when President Obama was elected, he campaigned on global warming as being one of his main issues he wanted to deal with. And he, under his leadership, they actually set up legislation called the Waxman-Markey Bill, which would have set up a cap and trade system for global warming in the US. So the way this worked, it was called the American Clean Energy and Security Act, ACES. And how did this work? So basically, firms would face limits on their emissions. They could do this by reducing their emissions. They could, or they could purchase pollution credits to offset their emissions. Okay? Now, these emission permits would then be sold in a fluid market, and firms could buy them, and ultimately the idea is they would, ultimately the emission permits would essentially be what the cost needed to be to meet our emission targets. Okay? They wouldn't necessarily be the $200 a ton, which is optimal, but they'd be, we have some target to meet, we'll set a price such that we meet that target. Okay? Now, a couple issues is raised. The first was, who is going to pay for these emissions, for the cost of pollution? You have emission permits, it's less than what we're polluting today. That means there's costs on people who are going to have to reduce their pollution. And those costs, typically borne by utilities, would be passed on to consumers. What's the general consensus of economists and politicians alike? And the view was that you would end up with large costs passed on to consumers. So let's take my utility in Ohio that's super dirty. I'm going to buy a ton of emission permits. Well, I have to pay for them. How do I pay for them? I raise the price of what I'm charging for my coal, for my fuel, for my power that I'm generating. Okay? So basically, you have a situation where there is going to be a significantly increase in the price. In fact, that's kind of the idea, right? If you think about a cap and trade system, it's kind of a backdoor way of getting at the same level of taxation. Okay? Remember that if you go back to figure 5.9 in the back of the handout today, remember the cap and trade gets us to the same level as the tax. So really a cap and trade is kind of a backdoor way to get a tax, but without calling it that. Okay? Well, people don't like taxes, and they saw through this and said this is going to massively raise the price of energy in the US. Now, the developers of this bill had an answer to that. They said, well, what we're going to do is we are actually going to give these permits, the initial allocation of permits, we're going to give to firms today in proportion to how much they pollute. So a firm that pollutes a lot is going to get a lot of permits. A firm that pollutes little is going to get, and it's based on past, so it won't distort what it says, it's based on past. And then that way, John's dirty coal-fired plant doesn't have to raise its price as much because it gets a lot of permits. Okay. Well, that was criticized for two reasons. And the CBO said that would lower the cost to consumers a lot. There's two problems with that. We don't want the cost to consumers to be lower. We want the cost to consumers to be higher. That's how you end up using less fuel. That's how you end up using less carbon intensive. So it sort of offsets the very goal of the policy. The second problem is that's an incredibly inefficient way to use an incredibly valuable resource. What should the government do to allocate these permits? Government's got a bunch of permits. What should it do?
Sell them to the highest bidder?
It should auction them. Think about the money the government could raise. So for example, another thing like this is the government owns the spectrum that all our cell phones and things go over. The government used to just give away that spectrum to cell phone companies. Now it auctions it. And the auction is designed by economists, another big victory for economists, and makes a lot of money every year from these auctions. We should do the same thing with these permits. This is a valuable resource the government owns. The government is saying we're regulating, you say it's a resource. The government should auction it and take that money and use it to help people. So the efficient system economists would say is auction the permits, take the money, give it to poor people who face higher fuel prices. Remember the argument for free trade I talked about in 1401? The idea is, one party loses, one party but wins, but the party that wins by more. You take that extra and redistribute to the party that loses, everybody can win. There's a similar argument here. The problem is politically, the utilities said, no, if you're going to do this, we want the permits. So that was the problem with how they were going to do that, with how they were going to distribute them. Okay? This legislation, despite these problems, actually passed the House of Representatives, but was killed in the Senate. It was just viewed as too difficult, raising the price of energy, too easy to kill this with talking points. So we tried taxing, didn't work. We tried regulating, didn't work. So President Biden turned to a third approach. The third approach is if you can't tax the bad thing, you sure can subsidize the good thing. And so the third approach, which was in the Inflation Reduction Act, was a massive set of subsidies for moving away from fossil fuels towards clean energy. The subsidies came in multiple forms. First of all, there were subsidies for production and R&D on new types of energy. There were subsidies for and so that was one big spend. Was basically like billions of dollars to develop hydrogen alternatives, electric alternatives, billions of dollars for R&D into new energy alternatives. The second big expenditure was money to consumers to get them to switch to more energy efficient alternatives. So a $7,500 tax credit for buying an EV. Money if you fitted your house to make it more fuel effective, et cetera. So basically a massive subsidy towards fuel efficiency. Now, in a standard economic world, the subsidy is the opposite of a tax. Taxing the bad thing is the same thing as subsidizing the good thing, but not as good for two critical reasons. The first critical reason is the car example I gave you a few minutes ago. We're giving people EVs, so they're just going to ship their gas-guzzling cars to other countries. If there was a global tax on carbon, those other countries wouldn't use the cars either. That's the first problem. The second problem is it costs money. With one, you raise money. With the other one, you spend money. Now, you'll talk about Chapter 4, not this week, but next week in section, or I guess 2 weeks, because next week's a holiday, in section. And we used to kind of care about deficits. We don't really anymore. So that was sort of the insight of Biden was, look, this is the right thing to do. There's no other way to do it. Nobody seems to care about deficits anymore. I'm going to spend, $500 million, or it's actually $389 billion, $389 billion, moving us towards a clean economy. And it was the most significant piece of legislation in fighting global warming in our nation's history. And the question is this the sad lesson we've learned? That in fact we have to do the wrong thing if we want to do the right thing. And that's something we'll just have to see over time. Now, last point is where are we now in the world? Well, the most significant recent round was the Paris round of negotiations back in 2015. The Paris Agreement was an agreement to, this is under President Obama, to significantly reduce emissions around the world. The U.S. signed it, but it's all voluntary. Nobody comes in and pounds me if you don't do it. It was a voluntary agreement. It was a very significant agreement, which was signed by 186 countries. So it's broad in developing countries. It set up a very significant set of goals. Okay? The U.S. in particular, we pledged to reduce greenhouse gas emissions by about 26% below 2005 levels by the year 2020. Okay, or starting the year 2020. Basically, agreed to a very aggressive reduction. Without a plan for doing it, just we're going to do it. And other countries did too. As soon as President Trump was elected, we withdrew from the Paris Agreement. And then when President Biden was elected, we got back into the Paris Agreement. And, we'll see you can predict what's going to happen with this election. Okay? So, and as a result, we haven't done a whole lot. I mean, the Inflation Reduction Act that I just described is the one most significant investment we've made. You can contrast that actually with China. Now, once again, China did not get special treatment under the Paris Agreement. I talked about trying to buy China a special agreement. They didn't actually get it. And yet China's aggressively moved to regulate emissions. They're going to have the largest emission trading scheme in the world. They have already started one that involves about 3 billion tons of CO2 annually. They're doing set up an entire new climate monitoring system to make people aware of air quality and to fight it. And basically, it is working. They're actually reducing their emissions relative to the rest of the world. So this can be done. The answer is maybe it's harder to do in a democracy than with some places it's not a democracy. But it can be done, and the good news is coming out of China, even if once again, I don't want to poo-poo the Inflation Reduction Act too much. This was an important step. It was a major step towards fighting global warming. It's one that needed to be taken. It just would have been nice to the economists who could have done it the right way rather than the wrong way. Yeah? I'm not sure what the Europeans are doing. I mean, the Europeans are in a tough spot because they've already gone pretty far, right? I mean, how many people have been to Europe, seen gas prices over there? I mean, it's like twice what we are, okay? They've already gone pretty far to be a low-carbon economy. So their reductions on subsidies even more expensive than ours are. So I'm not quite sure where Europe is on this front. I think it varies a lot country by country. I'm not sure the EU has got a general policy, or each country was a signatory, not the EU as a whole. So I'm not sure what each country is doing. It's a good question. Other questions about this? Yeah, Enoch.
Subsidies are very expensive, like that's, yeah, we don't care about deficit. But if you look at like the cost savings from like a healthier like populace, like does it impact how it's
Yeah, this is a great general question we'll ask a lot this semester. One could call it general the offset question, which is to what extent can the fiscal benefits, we know we'll be healthier, but that doesn't count for the government. The question is being healthier have fiscal benefits for the government? We have to pay less to treat kidney disease. And is that, to what extent does that offset the cost here? So there's two answers to that. One is those are harder to measure, and so there's a lot of uncertainty in measuring them. Gets three answers. Two is, my wife says I should never give a number before a list because I always add one. Two is that the benefits are very long run, and politics is very short run. So that's a challenge. The third thing, which you'll learn, I'm not going to spoil it because it's one of the best parts of chapter 4. The way we do policy in the US says basically nothing matters after 10 years. And you'll learn about why when we do chapter 4. And that makes it pretty hard to justify something which is going to have savings in more than 10 years and costs in the first 10 years. But it's absolutely right theoretically. Other questions? Yeah.
You said like the first point from the subsidies was like the same outsourcing issue.
Yeah.
Is there a nuance between how the difference between subsidies and taxes?
No, but the difference, well, when it's US specific, there wouldn't be a difference. The difference is a tax you could be easier to coordinate worldwide than subsidies. A worldwide tax wouldn't have that problem. I was being a bit subtle on that. Good question. Yeah.
This is going back to like cap and trade for
Yeah.
for power plants as an example, but I think applies generally. Like, how well does how does it play out when you have a cap and trade scheme, but you're having something like a power plant with a natural monopoly, and like there's no do the people in the people supplied by a lone power plant that's really dirty, does that market just get sort of screwed because like they're gonna have to pay a lot? Their power plant's gonna
Well, I mean, the main thing is that's a great point. And there's a general question of over what geographic area do you want to regulate? So in other words, do you want to say it has to be nationwide below this level and everyone's do it equally, or we're going to allow for different areas? And once again, that's the point of a cap and trade system. So those people will be screwed potentially in terms of having to buy a lot of permits. But once again, if they're selling to a national energy market, hopefully that will be mitigated. I mean, this is actually a big, hopefully the permit price will come down. But those people, if you live a power plant, and that's why they allocate, unless you allocate more permits to them, then they won't be screwed. So that's why the ACES plan did it that way, was because if you give them more permits to start, they won't be as screwed.
I guess the question that I have is like, does the cost get borne, like that increased cost of having to buy more permits, ideally that would somehow get distributed throughout the market and everyone would have gas that's a little bit more expensive. But with an isolated power plant like that, an isolated sort of community, would it just be that they get a lot more expensive there?
It wouldn't, once again, if you did not distribute extra permits to them, then yes. You would have geographic disparities.
I have a question about, with the US Senate blocking a lot of these policies, what is the justification? With I think it's challenging, like we saw China do it. I'm European, and so I don't fathom like what is the justification? It's just they don't want.
Look, the Senate and the House are both bad guys on blocking stuff. I mean, basically it's just political calculus, and we'll talk about this in chapter 9. Like I said, it's sort of unfortunate in that politics underlies everything we do this semester, but only spend one lecture on it. But it's really just the view in the Senate was that people who, that politicians felt they'd lose their jobs. You know, when I was on the flight to Kyoto, one of the most fun parts, I got to spend about 3 hours chatting with a guy named Tom Foley, who was the former Speaker of the House. And it was a great conversation, and I felt comfortable enough with him, and I said, you know, look, I loved what you did as a Democrat, love what you did, except I really was upset you weren't strong on gun control. I think gun control is one of the most important issues in this country, and you would always oppose it. And he said, look, I'm from a district in rural eastern Washington. He said, my district cares about guns is one of the #1 voting issues in my district. He said, if I ran a company that did a bunch of good stuff and one bad thing, and fixing the bad thing would drive my company out of business, would you say I'm morally obligated to do that? And he said, I voted for gun control once in my life and I lost my job. And I was replaced by a Republican who does a lot of bad things. So it's, politicians are always making this trade-off of the many things they could do. And some politicians who care about global warming may have decided, well, if I vote for this, I'll lose my job, and someone who doesn't care about anything will take it. So that's the positive spin. The negative spin is they just want power and have these jobs, and they'll do anything to hold on to them. And we'll talk about that in chapter 9. Other questions about that? Okay, this is a very important area, and it's very, very significant for your generation to be taking this on. Okay, let's start with the next section. We'll do about 10 minutes on the next section, which is health externalities. Okay? And let's start with probably the most easiest health externality to think about. I'll explain why next time, which is cigarette smoking. Okay? Now, you guys don't think a lot about cigarette smoking because basically not many folks in your social circle smoke. Okay? But there's actually still quite a lot of smoking in the US. So if you look at figure 6.4, almost half of all Americans smoked in 1955. Today it's down to it's about 15% of Americans smoke now. Now 15% is still a lot. You might say 15%, that's 1 in 6. You might look around and say, look, 1 in 6 people I know don't smoke. Like, how can 15% of Americans smoke? The answer is fascinating. One of the reasons it fell was education. We started learning that smoking was bad for you. My wife bought me great at a garage sale, a sign from the 1940s of a doctor saying, smoke Chesterfields, they're good for you. We started realizing in the 1950s smoking was bad for you. So before 1955, smoking rates were about 45% in the US, and 45% of everyone smoked. Starting in 1955, smoking dropped, but mostly among the most educated, because they were the ones that could effectively more absorb and use the information. So in fact, smoking rates against the most educated are very, very low. So that's the folks you hang out with. Smoking rates among less educated people are still much higher because of various things, but one could be the information's just not been processed appropriately or fully. Okay? So that's why 15% may seem high to you, but it's a true national number. So still a lot of smoking. Smoking is a huge problem. Smoking causes 480,000 deaths each year. I'm sorry, go ahead, question.
How do they define somebody as smoking?
This is smoked within the last month. Smoking causes 480,000 deaths each year. That's more than HIV, illegal drug use, alcohol use, motor vehicle injuries, and firearm-related incidents combined. Okay? More than 10 times as many U.S. citizens have died prematurely from smoking that have died in all the wars fought by the U.S. Okay? Worldwide, it's even worse. There are 1.3 billion smokers alive today, and half will die of smoking-related diseases. Over 8 million people die every year from smoking-related diseases, and soon it will be the leading cause of death in the world. Now, that's bad. I think we can agree on that. Does that mean the government should be involved? And the answer is not necessarily. Because remember, smoking is a private decision where people weigh costs and benefits. And unless there are externalities, there is no argument for the government being involved. Okay? If I am someone who smokes and I sit on a rock in the middle of nowhere, okay, and never get medical care and never talk to anybody and no one cares about me, then why shouldn't I get to decide how much I smoke? Okay? So the only real argument in traditional economics for regulating smoking is the externalities caused by smoking. Now you might say, well, wait a second, John. Smoking's addictive. So isn't that a cause to regulate smoking? And the answer is no. Why? Why does the fact, absent externalities, why is even addictiveness not enough for the government to regulate smoking? Think like a Chicago economist. It's based on an article written by the Nobel Prize-winning economist Gary Becker in 1988. Why? Yeah, so if you're rational, homo economicus, you say, well, look, smoking this cigarette is going to cost me whatever it costs, $4 a pack, plus By smoking this, I understand I'm going to buy more packs in the future. So when I compute the cost, I compute the full cost to me, which is the effect on my health and the long-run cost to me of this additional cigarette. I understand that each additional cigarette cost, there's an extra marginal cost which makes me smoke more in the future. Okay? As long as I understand that, no problemo. Okay? So the fact that smoking is addictive, this is very important. It's very important to understand the basic economic case. The fact that smoking is addictive is not per se a reason to regulate it be above and beyond its externalities. Okay? So the main reason in a standard economic model to regulate smoking is externalities. Okay? So what are those externalities? Okay? Let's start talking about them. If you look at table 6.1, let's talk about externalities. Let's start with increased healthcare costs. By one estimate, cigarette-related disease increased U.S. medical care costs by $176 billion a year, about 8% of total medical spending. That's big. That's a lot of money. So you might say, look, $176 billion, that's an externality, so cigarette taxes should be set to bear that externality. Why would that not necessarily be right? Actually, I shouldn't have you look at the handout. Don't look at the handout. Why would that not necessarily be right? Yeah. Yes, exactly. Remember, externality definition has two parts. That your actions affect someone else and that you don't bear the consequences. So imagine the way all health insurance worked is that everybody bought health insurance for themselves and the price included the damage done by smoking. In that world, there'd be no externality. Okay? Because basically, I would internalize the externality because I would bear the extra cost my smoking does. Yeah?
In that example, would there be an externality to the insurance company or do we not?
No, there's no externality to the insurance company. The insurance company says, look, I've computed for you at your age and your background. This is how much it costs for smoking. Smoking's going to cost us. Now, there's a subtlety. There's a little bit of externality because, remember, we don't buy lifetime insurance. So the problem is the externality might be on another insurer. So there is an externality. There is an externality in insurers. This is a clever point. Externality insurers because the insurer you have today won't be the insurer when you're old. And then when you're old, it's going to bear the medical costs. So there's that externality. But let's leave that aside. Let's imagine lifetime insurance. Every individual buys on their own. It's in the premiums. No externality. This is very important. Reality, of course, deviates from that in a number of ways. The first way it deviates is people largely buy group insurance. So the cost of my health insurance is based on the health of the pool of MIT employees. So MIT employee smokes, my premiums go up. Okay? Because the cost of the pool of MIT. Now, that wouldn't be true if MIT could charge a smoker for insurance more. Before the Affordable Care Act, that was illegal. But the Affordable Care Act actually made it legal to base insurance premiums on smoking status. Okay? So that helps solve that problem. But there's also the fact that many people don't buy their insurance. For example, if you're on public insurance, Medicare or Medicaid, we'll talk a lot about those this semester, that's just paid for by the taxpayer, by your past tax payments. You're not paying. There's no way to charge you more if you're a smoker. Okay? If you are uninsured and you go to the hospital and get free care from the hospital, we're not going to charge you more if you're a smoker. So there is an externality from smoking, from the medical cost of smoking. But remember, that externality only exists in the world where people don't internalize those costs. Okay, I'm going to stop here. Okay, thanks.